Hi students, let's look at this question here, which was taken from the H2 Math paper, 2023 paper 2 question 2. Okay, so I think the first part should be quite okay. It's a quite a standard question. You are told to show that y equals to ln secant x satisfy this third order derivative equation here. Okay, so essentially it just means that we need to differentiate this 3 times. Okay, 3 times. That's the main point there. So we're going to start off by writing it down A. Now, usually what I'll tell my student is we arrange first before we differentiate. So in other words, just don't brute force differentiate this. So what I'm saying is, don't just differentiate this. Try to rearrange this into this form here. So this will be EY secant x. I think this will be a much pleasant experience in terms of differentiating the expression. Then from here, what you do is just differentiate with respect to x. Okay, so this case here, this is the implicit differentiation. Differentiating EY will be EY dy dx. Then differentiate secant x is from the MF27. This will give us secant x tangent x, right? From here, what I will say is just be mindful, because now don't differentiate straight again. Just understand that because EY is equal to secant x, so meaning to say this is my EY. Okay, so e to the power y. So this one EY equals to secant x. So you could just cancel the EY on both sides, right? So that's the idea there. We could just cancel. So I'm gonna replace this guy with EY here. This guy here with EY. Okay. So this case, I'm gonna get here, I'm gonna get EY tangent x, EY dy dx. Okay. From here, we could just divide both sides by EY. Just divide by EY, then you cancel this out. Then we'll get dy dx equals to tangent x. Okay, this is nice. Then remember, what we need is differentiate this 3 times, right? So we only did differentiation once. So meaning there are 2 more times in order for us to get this expression here, this equation here. So differentiate with respect to x. What we get is these the second order derivative equals to secant square x. Okay, so this is pretty okay. So same thing. We could write this as EY square. There you go. So EY, or we could also use the, actually there are many ways to do it here. We could replace EY in, because EY square in, or we could just use the formula here, which is like cosine square x plus sine square x, right? Equals 1. Usually what I'll say is try and know how to derive this formula here. Divided by sine square, cosine square x, right? What we get is 1 plus tangent square x equals to secant square x. Okay, we could just write secant square x as 1 plus tangent square x. Okay, we could just do that. So try to know how to derive this formula here, because this is not given in MF27. So from here, what we'll get is 1 plus tangent square x, okay, d square y dx square. Then I know that tangent x is dy dx. See that? Dy dx, eh? So tangent x is equals to dy dx. So this could be rewritten as d square y dx square equals to 1 plus dy dx entire thing square. Great. Okay, so there's that. Then after which, this seems more promising. We could actually just replace this in. Okay, this is not the only way to do it. I'm sure if you were to replace secant square x, okay, as e2y, it works as well. Okay, it's not an issue. So here I'm gonna differentiate once more. So differentiating with respect to x, what I'll get is d cubed y dx cubed equals to, this is 0 plus 2 dy dx 1, then d square y dx square. Okay, so there you go. That's what we were told to show, right? That's the expression there. Okay, done. So let's look at the part B. We need up to the term x4, meaning to say we need d4y dx4, right? Okay, in other words, we need to differentiate this once more. Okay, that's the main thing there. So for part B, you have to know, whenever you do Maclaurin series, right, you have to know where you're stopping. If not, you have a problem, because it's an infinite series. You will have to, the question has to imply where you should stop, right? This case here, I put an eye on where I want to stop, which is d4y dx4, right? So this case here, differentiate with respect to x. Okay, to be mindful here, we need to use product rule. So the one on the left is d4y dx4 equals to 2. So this case here, we have got u and v. Here, okay? So we have 2. I'm going to bracket it. So u dv dx will be d cube y dx cube plus d square y dx square. Then this will be d square y dx square. Okay, so I know this is where I should stop. Then we'll try later. Here, okay. So done. Then once we are done with it, we could go and find out what is y, the value of y when x is 0. Okay, we need y, then we need dy dx, and we need d square y dx square. Then we need the third order derivative and the fourth order as well. Okay, so this is the power 4 dx4. Okay, that's it. So just go and hunt for each of them. I think the easiest is when x is 0, secant, so here, y this value here. So when secant 0 is 1, so ln 1 is 0, right? So when x is 0, cosine 0 is 1. So secant 0 is 1 over cosine, which is 1. So ln, so y is equals to ln 1, which is 0. Okay, so this is 0. I'm going to fill this out at 0 here. Okay, then go up to dy dx and find. So here, dy dx will just be 0. Tangent 0 is 0. So here, 0. Then we go to d square y dx square. Is this guy here? This is d square y dx square equals to 1 plus 0 square, which is 1. So I get this as 1. Okay, so go and treasure hunt. So d cube, this guy will be 0, right? This was 0. So this entire thing is 0. Not an issue. This is 0. Okay, this is 0. Then d4. We need d4. d4 will be this guy. So we have this as 0. So when it's 0, you don't need to worry. 0 multiplied by anything is 0. So we just leave it there. So d square is 1 times 1. So in this case, I'll get 2 here. Okay, get 2. So just using Maclaurin series. What we get here is just use this formula here. So what we have is fx is actually, fx is what? Fx is ln secant x, right? We need y. So y is given by, this is my f0 here. Y dy dx, d square y dx square, and so on. So I'm going to just put this in 0 plus x. 0 plus x square over 2 prime. This will be multiplied by 1 plus 0 plus x about 4 factorial, and multiply by 2. Okay, that's it. So once we're done, we get x about 4 over 4 times 3 times 12, 24. Okay, so this is 12. Okay, so that's that. X about 4 up to the expansion up to x about 4. Okay, that's it. So once done, we move to C by putting x to pi over 4, find an approximate for ln 2. I think this is pretty okay. So I'm gonna just part C, because now we know ln secant x is x square, is roughly x square over 2 plus x 4 over 12, right? So if you were told to substitute x is x equals to pi over 4, so I'm gonna just substitute x equals to pi over 4 in. Okay, when pi over 4, then you just replace everything, x as pi over 4. So ln secant pi over 4 roughly equals to pi over 4 square over 2 plus pi over 4 to about 4 over 12. Okay, so then once done, you just, now secant is obviously 1 over cosine pi over 4, which is actually 1 over root 2. Right? Pi over 4 is, cosine pi over 4 is 1 over root 2. Then we just gonna do this. This is pi square 1632. Then I'm not sure. This is quite a huge number. Let me check. Here will be pi 4 over 3072. Okay, so I think it's not too bad. Now cosine pi over 4 is we know cosine pi over 4 is nothing more than 1 over root 2. Okay, so essentially if you ln 1 over 1 over root 2, which is what we have here. Okay, so this will be just ln root 2. Okay, so I'm going to just write that down. Then this is ln root 2, roughly equals to 1 over 32 plus 1 over 307. Oh, we can just leave it. Okay, because it's we can't add them. Can't add up. Pi over 4. So once done, we could just we could just put 372. Then this is 2 power half. Power half can bring down. Is there a 2 here? There's no 2. Okay, so power half. This is power half. Once done, just multiply by 2 both sides. You will get pi over 2 over 16. We get pi over 2 over 16 plus pi over 4 over 1536. Okay, now remember to use your GC and check our answer. Don't leave it to luck. So you either use GC or calculator to check. So how do you do that? So usually what I tell my students to do is to bring out a GC, then you check it by putting in the value in. So like ln 2, right? Ln 2. This is the value here. Then you key in what you got as an approximate and see if the value are close to each other. It has to be roughly the same. Okay. So I'm gonna key in. This is pi square over 16. Okay, plus pi over 4 over 1536. Then you key in. Okay, these two values must roughly be the same because 0.69. Okay, then the other one with 0.68, so which is quite accurate. Okay, so it's approximate. It should be roughly there. Okay, so that's how you check your answer. So let's look at the last part, which is using your answer in part B, find the approximate for this. So I think it's pretty okay. Just use what we already found, right? So D is 0 to pi over 10. It's only 1 mark. Be mindful, it's only 1 mark, so we can just use GC. So pi over 10. So this is roughly approximate 0. Ln secant x will be this guy here. So x squared over 2 plus x to the power 4 over 12 dx. Okay. So what I would suggest is just key in calculator, because it's only 1 mark. There's no way. I mean, you could just integrate and substitute and everything, but you save time by keying calculators. X squared. So we just key in calculator here. Bring out your GC. What you need to do is just put math, then go to number 9, function integral there. Then you just key in the value here. So here I'll have a 0 to pi over 10. Then I'm going to key in the values there, which is x squared over 2. X squared over 2 plus x to the power 4 over 12. And put the x here. Okay, then key in. That will be your. They want 4 as f, right? There you go. So remember to save time by just keying GC. Okay, so that's how I do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.